the alternating series reminder is, it requires to have an alternating series. If a series has terms that are alternating, decreasing in magnitude, and having the limit of 0, then you know that that alternating series converges so that it has a sum. We call the sum S. If the sum S is approximated by the nth partial sum, meaning S sub n, then the error in the approximation, we call it R sub n, which is going to be the remainder, and we call it remainder or error. So you have that the error is going to be equal to the basically the original minus the approximation, and this one will be less than the absolute value of the first omitted, or what we call the truncated term, okay, which is going to be a sub n plus 1. Okay, in other words, if the three conditions are met, you can approximate the sum of the series by using the nth partial sum and S sub n, and your error will be bounded by the absolute value of the first truncated term. But what is this truncated term? You're going to see that it's not that bad. Okay, so let's look at this example. Let me get more space here so we can see the first example. Okay, so we have this series, which is an alternating series. What we need to do first is we want to approximate the sum S of the series using the first 4 terms. Okay, so if you want the first 4 terms, okay, let's A. You want S sub 4, okay? So you know that S sub 4 is going to be equal to what? Okay, this is going to be equal to 1 divided by, and your series here, 1 factorial, okay? And it's going to be positive because negative 1 to the power of 2 is positive. The next one is going to be negative, so you have 1 divided by 2 factorial. Then you have plus 1 divided by 3 factorial minus 1 divided by 4 factorial. When you plug this in the calculator, you have that this is 0.625. Okay, so this is the approximation that they were asking for. Okay, and you're going to see how this theorem works. Okay, so check this one, check. Now B, explain why the estimate found in part A differs from the actual value less than 1 over 100. Okay, so here's where we are applying basically the theorem that we were talking about. Okay, so we know that this series first alternates, okay? Then the second condition that we have is it's the limit when n goes to infinity of 1 over n factorial. We know that this is going to 0 because this is getting humongous, okay? And the third condition that you have here is decreases in magnitude. Why you know that it's decreasing in magnitude and why we know that it's true. Okay, so you know that the first one is 1, the second one is going to be what? Negative 2 factorial, which is 2, 1 over 2 factorial, okay, which is this. Okay, then you know that it's going to be positive and it's going to be 1 over 3 factorial, which is 6, and so forth. So it's decreasing in magnitude. Okay, so we are meeting all the conditions. So what do you know? Okay, so you know that the remainder, the absolute value of the remainder, is equal to, remember, the error. Okay, what was the error? The error is equal to R4, which is equal to original S minus S sub 4. Okay, and we're going to say that this, we want it to be what? We know that the theorem says that this guy, S minus S sub 4, is less than the first truncated term, right? What in the world is the first truncated term? Well, you know that the last term is the 4th term, so the first truncated term would be, in this case, the 5th term. Okay, and please note that it's the absolute value of the 5th term because it's alternating. Okay, so what do you know? Okay, so you have that this, okay, or if you want to call it error or however you want to call it, doesn't matter. Okay, is going to be less than what? What's the 5th term? The 5th term is when you plug the the 5 here, right? So if you plug the 5, this is going to be, well, it's going to be positive, but honestly, you don't care about that. And then you have that it's going to be 120 because 5 factorial is 120, okay? Which you know that this guy, 1 over 120, is clearly less than 1 over 100, okay? Which is completely true, so check, okay? We know that it's completely true because this is the 5th term, okay? We'll go with that. Okay, so done. We check. This is my explanation. I know that it's a very math-like explanation, but well, we're in calculus, so that's the explanation that we are looking for. Okay, so your explanation is the 5th term, aka the truncated term, is the absolute value is less than 1 over 100, and that's why it works. Okay, so for C, what you have is we need to use your results to explain why S is different than 0.7. Okay, so what do you have from the results? From the results, I know that I have this equation, right? And we know that this is less, okay, less than 1 over this, right? Are we okay with this? Okay, so what values do you know? You also know that this S4 is not S of 4, right? It's what? 0. What was it? 625, okay? 120. Okay, so how can you get rid of the absolute value? Using your algebra 2 information, you know that if we want to take out that absolute value, you have that this goes here, and then I basically take out the absolute value, okay? After that, if I want to know, if I want to leave my S by itself, what are you going to do? You are going to add 0.625 here, here, and here, okay? So when you do that, you have that it's 0.625 minus 1 over 120. Then you have S alone, and then you have 0.625 plus 120, okay? And then you have, when you do this operation, you have that this is going to be 0.617 S, and then you have that this one over here is going to be 0.633, meaning what's your this is basically the interval of convergence, okay? So you know that S, it's not 0.7, okay, because it's not belonging to this interval. Thus, S is different than 0.7, okay, because it doesn't belong to this set. And that's it.